Good afternoon, everybody, and thank you for attending our session today. My name is Jeff. I'm here with my colleague Kishore, and we're here to talk about containers, Kubernetes, and KPIs. Real quick, though, we both work for Fidelity Investments, so wanted just to tell a little bit about our company. So we're a large, privately held financial services company. We offer mutual funds, brokerage services, retirement accounts, wealth planning systems. But there are a few things that we're known for in the industry. We're known for trust, reliability, and being innovative from a technology perspective. So we kind of joke internally that we're a technology company that just happens to operate in financial services. And what we believe as an organization is that we move into the future, the way that we're going to be innovative and be able to provide next generation products and services for our customers is going to be by adopting cloud computing and the promises of cloud services. Our cloud journey began in 2026. Fast forward to today, we now have over 6,500 applications running in prod, with an organizational goal to have more than 90% of our application portfolio in the public cloud by the end of 2026. Real quick, just want to walk through what we're going to cover today. So we'll take a look at some industry and Fidelity numbers around containers and Kubernetes adoption. We'll take a look at our cost optimization KPI. It's an index KPI. There's 3 primary pillars or objectives. Deep dive on the third, which is our underutilized pillar, a little bit more. Then I'll pass it off to Kishore. He'll provide an overview of the Kubernetes architecture, the primary components, and our first look at segmenting that environment from a responsibility perspective for FinOps and personas there. And then finally, just taking a look at what we're doing today from an optimization perspective and what we'll be looking to do in the future in this environment. So by a show of hands, how many people today are running containers or Kubernetes in their production environments? Yeah, so that's pretty similar to what we're seeing. So recently, CNCF, their annual survey, we were able to pull some information out of that. And 79% of those that responded are running at least a few production applications in containered environments. There's another 9% that are actively looking. So we're talking almost 90% of those respondents are running containerized applications in prod or will be soon. And the other interesting number is 50% of those are currently using Kubernetes as their primary orchestration engine for containers. So looking at the Fidelity environment, right, we have hundreds of clusters, we have thousands of containerized apps in prod, we have hundreds of thousands of containers running, and over the next 1 to 2 years, we anticipate these numbers to double. So it's really important for us as an organization to make sure that we understand that environment and we can measure it effectively from a FinOps perspective. So real quick, want to go over our cost optimization KPI. As I mentioned earlier, it's an index, so I won't spend too much time going into detail because Zach and Noel last year did a fantastic presentation, so you can check that out on YouTube. But as I mentioned, there are 3 primary pillars of this KPI. So there's a total score of 100. First pillar or objective is purchasing effectiveness. This is measuring our discount on reservable services. This is something that we manage, that's managed from the central FinOps team. The second pillar, unutilized resources. So this is just resources that are no longer used or not actively being used. So we look at orphan load balancers. We look at snapshots, volumes, as well as looking at shutting down instances that are not actually being used at nighttime or over the weekend. And this particular pillar is managed via automation, again by a centralized team. Where it starts to get a bit more complex for us is when we get into the third pillar, which is the underutilized assets, and that's where we're measuring our compute utilization from a memory and a CPU perspective. So those first 2 pillars, right, we can centrally manage that, we can put some automation in place, but when we start looking at this third pillar, it's where it's a lot more challenging because now we have to work closer with the dev teams. They have to make those changes sort of at the edge. And that's a little bit more difficult from a central perspective. This is, we see internally as a great opportunity to get more improvement from a FinOps perspective. So when we started to break down this pillar, we thought, okay, Compute's a large percentage of our spend. How do we break that down a little bit more? So we looked at the environment, and broke it into 3 primary segments. The first segment, standalone instances, right? That's a single app, that's a single, application contact, single primary FinOps lever to pull, right sizing. Our second segment, auto-scaled instances, right? Or load balanced instances. Still a single app contact, still a single app and a single contact, but now there's a couple of additional considerations from a FinOps perspective. Now you got to look at auto-scaling policies, you got to look at the number of VMs in addition to right-sizing the instances. And then the final segment, which for us is the biggest percent of the environment from a compute perspective, is clustered instances, right? This is a multi-tenant environment. Now we have multiple contacts, multiple applications running in there, and now we've introduced some more FinOps levers within the Kubernetes environment. So now you have to look at pod configurations, replica sets, you have to look at containers, and looking at request and limits for the CPU and memory. And this is, again, I had mentioned earlier, this is a space that we see doubling right now. So it's going to be even a bigger percent of our overall environment going into the future. And if I had to guess, it's probably going to be the same for a lot of people out there, which is why it's really important for us to figure out how to measure that space in an effective manner from a FinOps perspective. So this particular pillar, right, a lot of emphasis here on the underutilized pillar, it's gone through an evolution of time, right? So Fidelity operates in a federated model. We have a couple of dozen business units. So in 2020, we had a goal. We looked at the environment in aggregate. We did okay, right? But we realized, going into the next performance year, we had to start looking at it per business unit. Some business units, they met or exceeded the goals, did really good. Others, struggled a bit, which I'm sure is not uncommon. But one thing we realized during that performance year is now we have to start looking at memory too. So we worked with our engineering teams, we started collecting memory metrics. So going into 2022, now we're looking at CPU and memory. So we'd give people credit whether they were optimized for CPU or memory. Kishore and I's particular business unit, we did really well. We got that going back to that cost optimization. We hit 100 for our business unit. We're feeling pretty confident, right? Like, hey, if we just scale what we did in our business unit to the app teams and the other business units, then we can bring them up with us and they'll be able to see some similar goals and outcomes that we did within our business unit. So going to 2023, this current performance year, we didn't make any changes, right? Again, we just think, hey, we just figured out how to scale it, we'll be good. However, when we started working closer with some of those business units, we started working more with those app teams, we started realizing, all right, this particular environment, it's a lot more complex, right? It's different than our internal use case. And one particular thing that kind of really stands out where we really knew, all right, we're going to have to look at this environment and measure it differently is in a non-production space, somebody spun up a new cluster, a couple hundred nodes. It was one of the more expensive clusters in the environment. Started having some conversations with that team, made some iterative changes, making changes to auto-scaling groups and the minimum number of nodes in those node groups. After a couple of iterations, able to save almost 70%, which is fantastic. Those are the success stories you want to hear. However, when we took a look at the KPI for that particular environment, the underutilized pillar, we didn't really see a lot of change. And that was really kind of the watershed moment for us where we realized, all right, we're going to have to start measuring and looking at this space differently. So, going into 2024, we don't have the KPI figured out yet, right? But we're working on it actively right now. But it was at that same time when we, worked with that other business unit that we knew that we had to partner with the experts, right? And that's where Kishore and the Kubernetes team came in, where they're able to educate us more and help us kind of figure out what we're going to have to do to measure that environment and just give us more options from a FinOps perspective of what levers we could pull. And I'm going to hand it off to Kishore, and he's going to go over Kubernetes.
Yeah. Thanks, Geoff. So today I'll be covering a little bit of Kubernetes overview and then introduce different personas that we identified from FinOps point of view, and then also look at the complexities of Kubernetes, right? So let's dive into that. So why is Kubernetes relevant and how did we get here, right? Traditionally, organization purchases hardware, had it, the data centers, didn't have to bother about how much usage is there. so on, right? And then people ran VMs on top of that, and cloud came, people rented stuff. It's easy to spend money there. You run VMs on top of that. And with that, the next technology wave is containers. So we have VMs which can run 1 or 2 applications, and it gets complicated when each application have different dependencies, and then that's where containers came in and then helped you utilize that one VM to have multiple applications running with different dependencies. So it made it much more efficient for the VMs to be running, right? And running these kind of containers on one VM could be very complicated, right? And you have to scale it across all the applications in your organization. It's really complicated task. And for the system engineers, it gets really complicated. That's when the orchestration platforms came in for containers, right? Kubernetes has been like about one of the most successful one, as you've seen like in the previous slides. Over 50% of organizations that were surveyed were using Kubernetes and some form of applications in production, right? So this has evolved a successful container orchestration platform. And let's look at the current usage, resource usage of Kubernetes in this space. This is a survey done recently, 2023. So if you look at the numbers, it's just about like 30% of CPU being used out of 100% provisioned, and 80% of it, 80% of the memory is used. You see there is a big opportunity to sort of like utilize all the resources that is still like left over, right? And looking at the containers, container configuration, right? On a container, you can configure what sort of memory it needs, what sort of CPU it needs. And not configuring these values makes the cluster administrator's life hard to predict what sort of load a cluster needs to sort of like support, how many VMs they have to provision in the cluster. Not having these numbers, they'll have to over-provision the cluster, which leads into more costs, right? So this is another opportunity where organizations should look at configuring these values on their containers. And putting these two unconfigured values or badly configured values into dollars, right? So if you project that to the worst case, like where a cluster which contains like 1,000 nodes, it's pretty common to have like such big clusters with 1,000 nodes. You're looking at like $10 million of savings if you optimize these metrics on your containers and like have the applications configured correctly, right? That's a big opportunity. And there is a reason for like having this kind of wastage, right? It's scale. Like Kubernetes comes with a scale. You can have applications out of scale, nodes out of scale. Everything is like exponentially. If you have things configured right, then you have better usage. If you have something configured wrong, then that wrong configuration scales like exponentially. So that results in like lot of wastage. So it's really important to configure things correctly, right-size things. And let's look at the Kubernetes architecture. The goal is to sort of like show what sort of components are there on a high level and who is sort of responsible for what components, right? This is to sort of like showcase the FinOps side of things for each of these components. So here is like control plane, which is the brains of Kubernetes, where all the orchestration logic happens. When a container comes in, where to schedule the container, which VM to be spinned up, all this logic happens here. And this layer is the virtual machines, on which the applications are actually running on, any workload that will be sitting on top of this one. And you have the extension layer, which provides additional functionalities from the upstream Kubernetes, whatever that doesn't offer, right? Kubernetes is very extendable. You bring in your own add-ons onto the cluster to offer various functionalities. And you have the actual application layer where the end users, the application teams bring in their applications and run them in their mini clusters called namespaces, right? And here we have identified a couple of personas from this architectural point of view, who is responsible for what sort of things, right? One is platform engineer and cluster operations engineer, application engineer, and then FinOps practitioner. Let's dive into each of these personas' responsibilities in the architectural component, right? Platform engineer is responsible for control plane and the add-ons of it. they are primarily sort of responsible for making sure the control plane works for you and the add-ons are functioning appropriately. And if they don't configure things correctly at this level, snapshots of these cluster instances are going to be replicated across the organization, right? You'll have like hundreds of clusters. That's going to be that bad configuration is going to be replicated across the clusters. So this is where the platform engineers play a role to configure them. And then the operations engineer, they provision VMs on the cluster. They're responsible for primarily providing the compute for them, for the applications running on the cluster. They have to predict the workloads coming in and then right-size the cluster, the number of VMs provisioned on the cluster, so that it's always sort of like ideal for the number of workloads coming in. There is a little bit of slack for any sort of auto scaling, but not too much, right? So that's what this person is going to do. And then the application engineers, these are the end users of the cluster. They bring in their applications. They say, my container needs X amount of CPU, X amount of memory, and then they place in the namespace. There will be like a lot of these users. They have to coordinate with the cluster operations engineer, communicate the needs of compute, what they have on the cluster. The aggregation of all these needs would be transferred back to the cluster operations engineer. They'll sort of like make their predictions based on the combined requests. And then we have FinOps practitioner. So this is the persona who plays a role across the board. They interact with platform engineer, try to optimize things at the platform level, interact with the cluster operations engineer. They make sure the VMs are right-sized for the cluster. They communicate with the application engineers to sort of make sure their applications doesn't over-provision or their containers doesn't have a CPU, which is like ideally not used, right? And for a FinOps practitioner in Kubernetes to sort of like measure things, right? They have to have a way to measure things. There are a ton of tools to sort of measure things, but primarily the dimensions that they would use for measuring is namespace, which is like a smallest mini cluster within the Kubernetes cluster. Application teams can, Kubernetes clusters are multi-tenant. They can bring in their applications into a particular namespace, which is sort of like isolated. Other teams don't have access to that. And the other dimension is labels. Some applications can be deployed across namespaces, right? You might want to have a way to sort of like filter out based on some sort of a label, right? Label is pretty similar to what cloud platforms have, like tagging, right? So it's similar. So these two dimensions are very useful for FinOps practitioner to sort of measure and have a visibility of what is being used on the cluster. Yeah. And with that, I'll hand off to Geoff to talk about optimization Kubernetes.
Thank you. So as I mentioned earlier, there's some things that we're working on today and we're looking to work on in the future. So right now, what we're working on is from an auto scaling or a node group configuration. We're looking at ways, can we automate setting minimum size values in those lower level environments to just make sure those clusters are as small as possible. Mentioned before, right, we have some instant shutdown automation that we can do at night. We want to extend that into the Kubernetes environment, but do it in a way that gracefully shuts that environment down. And then also we're taking a look at instance sizes and node types, right? Does it make more sense to have a certain family and size instances in a cluster versus having kind of a mixed environment? Something that we're looking at in the next 3 to 6 months, right? We mentioned we got to figure out that cluster optimization KPI and what we're going to look at per persona in the Kubernetes environment. And then again, the personas, we have to make sure that we get the right information and the right data to those different personas because they're going to have different information needs and different calls to action from a FinOps perspective. And then looking into 2024, I've heard a lot in different sessions here about kind of shifting left. This is what we're looking at from that perspective, right? What controls can we put in place where it's more proactive in nature? You know, can we identify waste ideally before we provision resources in the environment? So we're going to look at infrastructure as code scanning to identify that, as well as look at implementing a governance gate process where we can kind of flag misconfigured items before they get deployed in the environment. So just real quick before I wrap up, just kind of wanted to close on 3 things. One, you know, for us, especially looking at the Kubernetes environment, collaboration is really important. I think the trend we'll see in the industry is as these services get more complex, just think of generative AI, ChatGPT, it's going to be vitally important that you're partnering with those teams that really understand the technology and the service so that you can identify those opportunities from a FinOps perspective to optimize value. Second, right, shift left where you can, bring information where the users are actively working. We know our users and our app teams are actively in Git, in code. What information can you bring them where they're doing their work day to day? And then finally, be flexible, right? As you learn more information about your environment, the service, you may have to change things based off of what you thought previously, but being flexible is going to be vitally important going into the future. Thank you very much, and we can open up for any questions now. Oh, and check this out for Fidelity jobs, please.
So we will be using the all-powerful talking cube for our questions. You have the honors.
Yeah, quick question. Lisa, I'll start from Forrester. You have an interesting subdivision of platform engineer. You talk about the platform, the operations. I've never seen that before, and maybe that's just the way you operate internally. Does it have any bearing on when you describe in FinOps personas about how you do the FinOps side of things?
Can you repeat the question?
You have an interesting division. You talk about platform platform
Yeah.
team, and then you talk about operations. And a lot of places people describe those as one entity. So I'm interested in why you did that and what implication that might have for how you approach FinOps
So-
Kubernetes.
At Fidelity, that has been the approach from the day one we have taken. So cluster instance is like one snapshot. Upstream Kubernetes offers like 1.4, right? So they develop Kubernetes in the upstream. And at Fidelity, we have a central team which sort of like takes that upstream, makes sure that complies with Fidelity's all the compliance and governance, adds any add-ons that are needed. And that same snapshot of cluster is snapshot of Kubernetes version is released as like internal version of Kubernetes, right? And that is used to deploy all the clusters. Like we have several hundreds of clusters, right? That central team is sort of like responsible for providing the snapshot of cluster, and that's replicated across all the clusters that are owned by business or business units internally. And each of those clusters will have operations engineer or like sets of clusters, right? Each business unit can have like a dev, QA, and then prod clusters. These clusters would be owned by like the cluster operations engineer persona. They would be sort of like managing the lifecycle of the cluster, adding VMs, and then making sure there is enough work, enough compute for provisioning future coming workloads. So that persona is there, and then we have finally the application engineers who's bringing in. So this has been the setup that we have had all the time, but there was lack of coordination between these personas, and then the FinOps organization, when they identified there is room for improvement, they sort of like helped us coordinate and bring in optimizations with all these personas, making sure the add-ons are right-sized, making sure the cluster operations engineer right-sizes their node groups, not provisioning too many node groups, and then at the same time interacting with the application engineers to configure their compute on the containers correctly.
And I'll just add real quick, I know different organizations will kind of manage things differently, but I think those personas, perhaps one person plays multiple roles within that environment, but at least from a FinOps perspective and optimizing it, we think that's a really good approach to is kind of look at it from that perspective.
So your optimization keeps right back to the organizational structure.
Yes.
How you optimize there.
Yep.
So that seems to be a unique value proposition for cloud native operations in FinOps, right?
Yep.
Okay, thanks.
Just a quick question about optimizing at the container level. Is it just the limit setting that is used to optimize at the container level? So not at the cluster, but at the individual container. Is that what you do?
Yeah. So primarily for the application team, that's the core metric to set the requests and limits appropriately for the container, so that there is some way of prediction for the cluster operations engineer to predict what is the load on the cluster, and then if the first step is to get their values on the cluster on the container. If the value is not there, there is no way to predict what is needed on the cluster. Our first journey is to sort of like have that numbers across the containers in the organization, which is a big task. Not every container have it today. We are sort of in the journey to get those numbers, which will sort of help the operations engineer to have a prediction of what is the load needed on the cluster, right? And then the next journey would be to sort of look at where is the optimization possibilities to see what is not rightly configured, and then configure them rightly based on the historical information, and also provide them insights with, hey, this is our future plan, right? Like, it's not there yet today. Our plan is to sort of like provide them insights into, hey, this is what you're using, and this is what you are asking for. Do you want to sort of like have soft gates at the non-prod environments to sort of educate them? You might want to optimize your compute ask.
And I would add just one other thing, is like your deployment configuration too, right? If you have that misprovisioned container and you have multiple pods in that deployment, you're just going to exacerbate kind of the unoptimization as well. So that's another thing to think about and look at.
And I guess you might have scenarios as well where the request and limit is set, but it's set too high. Would that be a problem as well? Or?
Yeah, that's definitely a problem. Like if it's set too high, obviously that indicates the operations engineer, okay, someone is asking so much. So if the VM doesn't have so much of compute, cluster autoscaler or whatever automation is there on Kubernetes will spin up a new VM for them. And then there is that VM sitting there with just this container asking for like 2 CPU and then like 16 gig of memory, but like you're probably using just like 200 microcore, and that's sort of like idle compute not being used. You're asking for it, the VM would be provisioned with that, but you're not really using it. Right sizing the container is really important at getting the FinOps right.
It's one of those kind of like death by 1,000 cuts, right? It's like if you look at one container, one deployment, misconfiguring it's not a huge deal, but when you multiply it across the whole environment, especially we have thousands of containers, hundreds of thousands, right? Thousands of apps. It's really can become a really big problem because that scale can again just.
All right. So my question is the role you have in FinOps in architectural decisions. It sounds like you're using Kubernetes for everything or most of your apps. How do you determine financially if an app maybe you should go on Lambda, or maybe I don't know if you're looking at Firecracker or some of the other alternatives to containers? Because in our case, we have a lot of spiky applications. We have a big EKS dumping ground, but we try to put the spiky applications on Lambda. I'm wondering if you've sort of just said no, EKS is, or Kubernetes is our thing, and it's sort of everything has to fit on there.
I mean, it is a strategy for organization, right? Like portability is a big thing, right? For us, is that if it's deployed there, then we can have portability between, on-prem or in the public cloud. But as I was mentioning earlier, we operate in a federated model. So these teams have, the bigger business units, they have some of their own FinOps teams, they have their own architecture teams. So it's kind of a decision that they can make, but the overall strategy is to adopt Kubernetes wherever possible.
Geoff, I have a question. And Kishore, where can they find these lovely folks find you later in this conference?
Great question. Right there. So yeah, please feel free to continue the conversation, out in the hall. I'll be at the, the aircraft carrier tonight. Would love to talk more or connect on LinkedIn. Thank you.
Best talk ever.
Thanks for watching that session. I'm sitting here in San Diego right after FinOps X. We hope you join us next year here live 2024. In the meantime, please subscribe to the channel and join the community. Get involved, join the summits, get in a working group, and don't forget to get FinOps certified. Because next year here in San Diego for FinOps X, it's going to be twice as big. Come join the party. Come meet your people. Welcome home.